I'm like, okay, let's have pizza here. So we got access like this. That's nice. So we have a piece of pizza. It's 1/8 of the. So what's the angle measure? So we have pi over 4, and what's the radius? 1. So big pizza. It's big pizza. So they want you to come up with an inequality. So in polar land, it's relatively straightforward. It's relatively straightforward. What is theta constrained by? What's the lowest theta value? 0. And what's the greatest theta value? What? Pi over 4, because it's one slice of pizza, not the whole pizza. What's the radius constrained by? 0 and 1. That is, this region right there is that, right there. There's your region, right there. Your pizza slice is rather nicely described in a relatively straightforward set of inequalities. All of the points, any point you pick, as long as theta is between 0 and pi over 4, and as long as the radius is between 0 and 1, you are on that slice. Any point outside of this won't fit in one or both of those inequalities. Understood? So for example, this point right here, let's say I pick this one. Can you see that point right there? Is that point inside the inequality? No. Which one is it? It is in the first one, because what's the theta measure for that one? The theta measure for that point is between 0 and pi over 4, but why isn't it inside the slice? Because it's too far away from the origin. Okay, so now they asked you to do it in rectangular coordinates. Can someone tell me why it's a little bit more challenging in rectangular coordinates? Why is it more challenging in rectangular coordinates? Yeah, exactly. The height is curved. So in this case, down is always at the origin. The enemy's gate is the origin. Down is always the origin. So down, there's no obstruction. The enemy's origin is down. Okay. In this case, though, when you're dealing with rectangular coordinates, down is now the x-axis, and that changes. How many inequalities are you going to have to use use rectangular coordinates on this one? How many different regions are you going to have to work with? Come on. It's interesting. It's interesting to need to find out where the showstoppers are, because the other class didn't like this question either. I'll rephrase my question. If you wanted to integrate and find the area of that slice in rectangular coordinates, how many integrals would you need? You would need 2 integrals. Why would you need 2 integrals, Suzanne? Yeah, exactly. You would need to break it right here. You have to do the same thing. You have to do the same thing. So if you're dealing with rectangular coordinates, let's label a few things. What's that coordinate right there in rectangular coordinates? It's on the unit circle. It's 45 degrees. Root 2 over 2. Good job, everybody. Root 2 over 2. Nice. Okay. What's this coordinate right here? Yes. And what's this one right here? 1, 0. Those are the points you need, and then you can do the rest. The last thing, actually, is what's the equation of the line that goes from 0, 0 to root 2 over 2? Y equals x. There we go. I like it. You're like simplifying it as you were saying. You're like, y equals root 2 over 2 over root 2 over 2. Oh, it's just x. Yes. Okay, so here's the deal. If you wanted to write the inequality that describes that region right there, the blue region, you need to bound x. What's the biggest x can be? Yes. What's the smallest x can be? 0. Now, if you want to shade below y equals x, what does y need to be less than? Y just needs to be less than x. And you also it needs to be greater than what value? What value is that? 0. Yay. That gets you the triangle right there, but what else do you need? That little cap, the half of a cap right here, this green region right here. What equation do we need to find if we're going to find the area of this green region? What do we need in Cartesian form? That arc, it's a circle of radius 1. What's the equation for a circle of radius 1 in Cartesian land? There it is. X squared plus y squared equals 1 in Cartesian land. Nice. But we want just the top arc. We want it written as a function. So what do we isolate? Y. So what is y going to be? The square root of 1 minus x squared. Why don't we want the negative 1? When you square root both sides of the circle, you have the upper part and the lower part. So why don't we care about the lower one right now? Yes, thank you. We're only looking at the upper part of this arc. So in this case, we want, what are the limits on x? What's the biggest x can be? In the green region, what's the biggest x can be? 1. What's the smallest x can be? Root 2 over 2. And what about y? What does y need to be less than or equal to? Just figured it out. 1 minus x squared. And what does it need to be greater than? 0. So this right here, this is the green region right here. Here's the green region. And yes, I understand that there's slight overlap here. I can't have it equal in 2 places. 2 over 2 doesn't make it. It's a little sloppy. Now, what's the point of doing this? Why did they have you do it both ways? Can anybody explain to me why they would have you do it both ways? What does it show you pretty clearly? Yeah. You really want to know how much pizza you got. And you're really hungry at the end of the problem with your pizza. Pizza's actually what they're feeding us at the Harvard Math. But anyway, why else would they have you do this? We did the same thing 2 different ways. What does it show you about the methods? Yes. Is this a heck of a lot simpler than this? Yes, it is. Yes, it is. This is great and straightforward. That, not so much. Not so much. Moving on, I'd imagine you had questions about 30? Who had questions about 30? Yeah, there we go. Square both. Oh, we can square both sides. But what is r squared equal to in polar land? X squared plus? Yes, you know that x squared plus y squared is equal to r squared. But you still, do you like having 3 variables in there? Oh, thank you. Yep. Do you like having 3 variables? Say no. You don't. But you do know that x is equal to r cosine theta, correct? Do you remember that as well? But what does r equal? So this is 2 cosine squared theta now. What do you see? 2 times 2 cosine squared theta. What do you see? What do you see? X squared plus y squared is equal to what? I highlighted it for you. 2x. Oh, we did this one yesterday, but we did a lot more steps. What can we do now? Remember this? What can I add to both sides? Or what should I? What? Cereza. So what do you end up with? Does this look familiar? You just showed that it's a circle of radius 1 centered at 1, 0. As you get more practice, you'll be like, oh, you'll be able to just look at it and know that it's a circle of radius 1 around 1, 0. That being said, it's on the AP exam, generally speaking, they give you lots of pictures of polar things. They don't have you graph polar things by hand. Is it really easy to graph polar things by hand wrong? Yes, it really is. So here's this picture. What are they asking you to find in this picture? What are they asking you to find in this world? Are we adding together rectangles in this world? You can speak. No, we're not. What are we adding together? What are we we're not calling them triangles. What are we calling them? Sectors. So we have a sector. Here's one of them, right? Here's another one of them. Excellent. So we have that formula, right? 1/2 of what? Alpha to beta. What's the rest of the formula? F theta squared d theta. Well, do we have the formula in terms of theta for the red? What is it? What is it? Oh, come on. No one else is looking at the problem? I have to scroll up. What is it? 1 plus cosine? It's 1 plus cosine theta? So we have 1 plus cosine theta squared d theta. I mentioned this yesterday, or was it the day before we met? I don't remember. I told you, where do you think the most common, or I told you where I thought the most common mistakes are in polar land. Do you remember? Limits. The limits. This right here, relatively straightforward. Like once you get the concept, you're like, great, I can do this. And then you make these really small errors on the limits, and then it just folds away. It ends up being a lot of points. Because on a question like this, the AP exam would say, here's the picture, state the integral, like find the area, and they would give you 1 point, they would give you 2 points for stating the integral properly and 1 point for the answer. How does the 2 points break down for the stated integral, do you know? They give you 1 point for this, and they give you 1 point for the limits. So if you don't get the limits right, you get that wrong. And then, if the limits are wrong, you don't get the answer wrong, right? Those points add up. There's only 108 on the entire test. Get the easy one. So in this one, you have to be very careful. There are lots of valid choices, though. Does it matter where you start scanning because you're going around in a circle? Does it matter? You can start here and go all the way around, right? You can start here and go all the way around. So does it matter truly? Not really. But pick numbers that are nice. So let's start out here. What's the angle measure here? 0. So we look at our function. Our function, remember, is 1 plus cosine. What's cosine of 0? 1. What's 1 plus 1? 2. So we're like, oh, that's 2. Why does that picture make you suddenly doubt whether or not that's 2 or not? Yeah, you're like, what the hell is that? If that's 2, what's that? You have to be really careful and remember you're in polar land now. Does anybody know what that value is? No, pi. Then you're like, pi, but if that's pi and that's 2, that makes no sense, right? What is it? So we actually had to check that. I glued it in here. I was like, really? It is. You can trace it in polar land. That is what? It is 2. Like, Q. We're all doubting our math because we thought, like, is it 4? Because you need to, no, it's 2. So you go back here and you say, okay, that's nice. So it starts here at 0. How far around do we have to go? How far around do we have to go? 2 pi, right? And if you go all the way around to 2 pi. So the stated integral for this one, is going to be 1/2 0 to 2 pi 1 plus cosine theta squared d theta. Yes, go ahead.
Why would it be if you're like going
right here? What did you get for that integral? Yes, 4 point what? 712. Excellent. Is that the answer to this question, though? No, the answer to this question, you have to. What do you have to subtract from that? You have to subtract pi from it. Make sure on these. This is really important. When do you round to state your decimal answers? At the end. Round at the end. If you round and then subtract, you potentially could be rounding again and get the wrong answer. Because if you get the third decimal wrong, it's wrong. So in this case, you subtract pi, and then you end up with 1 point. Anybody get it? 571. And maybe you've been around in the math world long enough. Does anybody know what that is? Yeah, it's pi over 2. And going back to something Lena was kind of glitching about earlier in class. Oh my gosh, the answer's nice, so therefore does that mean there's a nice method of solving it by hand? Theoretically, do you want to do it by parts? No. So first you draw this picture correctly and realize, okay, so I need to answer this question, I'm finding this area plus, a little shading here, it's kind of nice, plus the other one. And yes, they are symmetric. So when you do this, you need to use the formula for area in polar land, and that's going to be 1/2 alpha to beta f theta squared d theta. The challenge is you have an outer one, and then you subtract the inner one. So you have 2 integrals here. You have the inner one and the outer one. So if that's the outer one, you're subtracting the inner one. I'm just going to write it twice. So what's the easy one? The inner or the outer function? The circle. The circle's the inner one. That's the blue one, right? The blue one is the inner one on the inside. So this case, if this is the inner one, what's that going to be replaced by? The square root of 2 squared. And remember, I'm not doing the limits of integration yet. So we're subtracting that out. Nice. The outer one, on the other hand, what's the outer one going to be? 1/2 alpha to beta. What's the function? The square root of what? 4 cosine 2 theta. Because that function, the function you want right here, this, if you're doing on one side, that is it. How did you get the square root right here? Why did you get the square root there? R squared. So the upper one is the positive. So the one on the right is a positive one, and the one on the left is a negative one. Because positive R values go that way, negative that way. Yes.
not all of what's inside the circle is also
2. What was it? 4 cosine 2 theta? And you know that R is equal to root 2. So you have to do some trig here. You take that, you plug it in, and what do you end up with? 2 is equal to 4 cosine 2 theta. So cosine 2 theta is equal to what? 1/2. So you know that cosine inverse of 1/2 is 2 theta. You have to remember here, what's the inverse cosine of 1/2? I don't know why I keep on writing negative. I did that last class. I don't know why. No. What is it? Pi over 3 equals 2 theta. So what does theta equal? Pi over 6. So now you plug in pi over 6. So it's going to go from negative pi over 6. So I'll just write, you know what I'll do instead? Sorry. I'll say this. Alpha is going to be negative pi over 6. And what's beta going to be? Pi over 6. There's one other type of symmetry you could notice to clean this up a little bit. What is it? It's not only symmetric across the y-axis, it's also symmetric across the x-axis. So instead of going from negative pi over 6 to pi over 6, where can we start the scanning? 0 and go to pi over 6. And then instead of a half out here, you plug in a 2 and a 2. Does that kind of make sense, everybody? Oh, but wait a minute. This statement right here is only this half, right? This statement right here is only this half. So to get the whole thing, you need to multiply by 2. If you replace by 0, you have to double it again. Is it really, really easy to multiply by the wrong constant? It is. If you want to see the cleanest way I know how to write this, it's going to be 4 times 1/2 the integral from 0 to pi over 6 of 4 cosine, so not 4, what is it? It's 2, right? It's 4, sorry, it's 4, you're right, yep. Where is it? It is right. Yeah, you have to be really, really, really careful about it. So I can find it here. I lost, there it is, right there. 4 cosine 2 theta minus 2 d theta, like this. So each one of these right here, ignore the 4, this right here, what is that an area of? It's this shape right here. That's what this, yeah, this right here, at least I'll put it here, this is that. And how many of them do you have? 4 of them. Oh, there's a square, yeah. No, the square's gone because it was the square root of this squared and the square root of 2 squared. I just simplified it a little bit. Yeah. Just combine them first, please. It's 0 to 2 pi. It's going to be 3 theta squared d theta. And as far as I remember, I think it comes out to 4 pi cubed or something like that. Comes out to 4 pi cubed? Yeah, I think it does. Excellent. Okay, picture.